Okay, got a bunch of us. I didn't get started early. Thank you. Glad to see Chris, Matthew, Reagan, Sarah. We're going to work on chapter 16 today. I think we had exhausted everything in 15 that we needed to do. And in fact, on 15, and I want to find that where we did that work and we created that statement. Let me pop over here for just a minute. We did the fine. Okay, yeah. We had ended up in 15-12 over on page 5A5, where we had that. Was that it? Where we took we took a list of expenses and turn them into a balance sheet or a little ledger. I want to find that, but that's where we'd stopped. So we've done 15, and we talked a lot about the importance of unions, union all, and we did all that business. So I think we're ready to launch into chapter 16 and take a look at it. Now 16 is going to be, there's one part of 16 that I'm going to steer you away from, and you ought to have your book with you and go over to page 599. And then just across from it is what would be page 598. Yeah. And that's basically the table of contents for the chapter. Okay. Now, we're going to look at cross joins and self joins, but we're going to stick crosstabs queries. And the reason I'm going to is because they're just terribly cumbersome to work with. They're difficult to work with. And I think you can get a lot more mileage if you take a data set or a view or a result set, whatever you've got, and export it to Excel and throw it into a pivot table. Or run an Excel crosstabs. I think you'll just come out ahead because the crosstabs function on Access is very, very limited. And there's a reason. Access is not a spreadsheet tool. It's a database tool. So we'll probably, I'll steer you clear of that, but we will work with the joins and the cross joins. Now, again, just to kind of set the stage for where we're at and what's going on. The main reason that union all, inner joins, left outer joins, right outer joins, those are important is because we're linking tables. And so when we start to link tables, if we link enough tables of relevant data, patterns start to emerge. Especially if we use a union all, okay, where we go ahead and retain the duplicate records because union, of course, doesn't provide duplicates, but we can use duplicate records to, I guess if you want to say, to mimic or mirror additional record-related material. And you say, what do you mean? Well, a record that's like a transaction record, okay? Somebody purchased something at a given time, blah, blah, blah. So with that being said, then we're going to move over to 16, okay? And we're going to talk about how we can take a table and perform cross joins, and then we'll look at using the self join. Okay, and that's going to be a process where there'll be some steps involved. Now, before I go any further, I want to make sure that we know what's going on in terms of the class and the flow of it, because we are now at week 10, and we've got you had the 13, 14, 15, and I gave you a file there, 13 and 14 to upload for your workshop credit. And you should, if you were here Thursday, either virtually or in the classroom, we did 15, so you should have a 15 to upload. Okay. Now we've got some other exercises that are coming up, and these involve the BI text, that's the sharded text, and we've just kind of jumped into it. So here it is, okay? And that's what the text, and you should have it by now. I would hope you do. And let's look at the, this is over chapter 3. This deals with warehousing, okay? And what I ask you to do is to go over to teradata.com for web-based courses on data warehousing. And I think I meant TUN, Teradata University Network. So let me go in here for just a minute, and I'm going to edit this real quickly, okay? And it should be, let me try Teradata. No, I think it's over there. Let me try this for just a minute, because this is, I'm just wondering if this is a singular critter that I can link into without having to go through Teradata. So let's hang on here for just a second. I want to take this shot and see what we get. Okay. Yeah. Okay. Yeah. So we could try. Yeah, we'll try. Yeah, it's Teradata Consulting. That's what I was thinking. All right. So that one's going to be okay. So we'll go back here. But I want you to write a report about what you've discovered. And now, now, let's do this. Go to the Teradata University Network instead. I think that's where we're going to find some courses, because those guys had some, but I think they've taken them down. All right, so I'm just going to do it right here. TeradataUniversity.com. So I want you to go there. University. That ought to suffice. I'll tell you. And or for web-based courses on data warehousing. Now, let me say this. If you don't find some courses in Teradata, I'm fine if you go out and just do a search out in Google, because I know you'll find some stuff out there. The whole idea is to get some courses that are out there about data warehousing and get some information about them. And that's all. And the whole point of this exercise is just so that we can reinforce that concept of the data warehouse. Now, if I was teaching this course about 3 to 5 years later, I'm going to be talking about also that we're going to be talking about what they now call a data lake. The warehouse is not big enough to contain, and what they mean, you'll hear people use this term when you're out at work, a data lake. And what that refers to is unstructured data, okay, plus structured data. Unstructured data, as I've said before, are data that are not easily assembled into a table. They could be tweets, they could be data points on Yelp, they could be likes or reviews on Amazon, and so it could be the number of nodes in some nodes between the middle of a network or the network originator, send Twitter, and how many layers of people does it go through till it starts to die out. And there are some tools out there that you can use to analyze a Twitter sphere and to see which nodes, and what you can almost literally do is construct how an idea gets communicated, or data from sensors, etc. Okay, so go out to Teradata University. If that doesn't work, go out and find stuff on the web, and when you do, please go ahead and please go ahead and make sure you have the documentation for it. Now that's one of those. It's out of the sharded text, and then there's an article from Time Magazine about data mining. Okay, and I want you to review the article and answer a couple of questions about it. And again, this is to just get you. In fact, to tell you to go to Teradata University, I'm pretty sure I saw the article over there if I'm not mistaken. But the whole idea is to get you understanding about this whole concept of data mining and what do we mean by that. And I've talked about it to a certain extent in the course about how we do drill down. Okay, so we look at and we look through column functions that let us add things up or get an average or whatever. So when we have counts of data or we have dates for transactions, so we can handle. We also talked about row functions, which are typically going to be something where we convert the stuff that's in the row. Okay. For example, we used the integer function to take some numbers and turn them into integers. We did some mathematical manipulation of data in rows. We provided operators, and say we updated the prices in a table or something of that nature. So we've worked through those pieces. Okay. The next is, okay, once I've got that data there, now what do I do? Well, the next step after you've created a data mart, a data warehouse, data mart, maybe databases, and all of these terms are used interchangeably, so it can be a little bit confusing. The process of data mining is the process I use to extract information from the database. And I think I heard. Did somebody have a question, comment? Anybody? I thought I heard a question there, and I didn't want to just run by, not answer it. Okay. If you do, I'll be on the lookout for it if you want to throw it through the chat system. So those are two exercises that I've got for you that are due this week. And to just firm up this notion of the process, the process of when we talk about data mining and all of these, it's really nothing more than I drill down, okay, to data that I drill down and pull out data that I want to pull out, just like if I were mining for if I were after a mineral that was extractive, I'd take out this whatever I can do now. I guess I could take out part of a hill and find the copper in it or something of that nature. And so that's basically what the authors are referring to. And so that kind of sets the stage for us, or the table for us, as we come down to these last parts of the book and really towards the last of the course. And that's for a very simple reason. We move from just having to do some code and manipulating stuff and running some queries and getting comfortable looking at that. And now we're kind of going up into the big picture of strategically, how do I approach this? Okay. How do I use this very powerful tool that I have? What do I do with all of this data? And it's important because it costs money to get data, it costs money to store it and keep it, and it costs money to use it when the time comes to use it, if you ever discover that you can. And most companies are sitting on probably a gold mine that they just haven't learned to work. And so this piece about data mining and extracting, drill down, we're also going to see about drilling across and drilling diagonally. And I know that sounds strange, but those are good models for understanding how we're going to go into the data that we've got and try to pull some meaningful information out of it. And based on that information, try to pull some meaning, some wisdom, or some knowledge that's going to be helpful to us in the long run. So I wanted to alert you to those and try to put them into some kind of context so that you would you'd have a sense of, well, why is he doing this, or why is he asking us to do this? And that's the reason why. Now, as I said before, we're going to work on 16 today. And so you'll want to go into chapter, you want to go in and get your files. If you haven't downloaded the files, the Patrick materials, you'll want to do that. So we'll open that up. And I'm just going to get that warehouse out of here, this SQL file. And I'm going to do that. Okay. You say, why do you keep calling this a warehouse? I keep calling it a warehouse for a simple reason. It has a set of base tables that we work with and we add to, and etc. So when you have that, that's really your data warehouse. Now, data mart is just, it's on a smaller scale in terms of fewer records. But my definition of it is this. A data mart has a highly selected set of tables. It will have a very, very limited set of views, i.e. results of queries. And that's because it's specialized, okay? That's the best way that I know to explain to you the terminology. And it's, we do the best we can to try to come up with these terms or concepts. And I will add this parenthetically. When you run a query today, when you've seen the queries that we run, you copied and pasted them in, they are nowhere as near complex as they used to be when you literally had to pull data from and assign data to, okay? The literal physical addresses within the machine. Because we have the GUI, that's the graphic user interface, we have a picture that represents that process for it as we go. And if you've taken a course with me where we've done macros, that's what's going on. But the macros below are hidden so that when you click on something, it executes, etc. Well, that being said, we've got SQL fun out there, and then I'm going to find the code for 16. And I know it can be a little didactic. I'm going to copy this, and then I'm going to paste it outside. All right. But it's important to me that you understand why you're doing what you're doing as much as you just understand what you're doing. Because when people say, we're not getting out of IT what we should get from IT, we're not getting the productivity. And typically my answer is this. It's you're the one who's running the machine, and you're the one who's supposed to be smarter than the machine. A computer doesn't know your business environment. It has stuff stored, but even these artificial intelligence systems, trust me, they are nowhere near what your mind can do as a human being, which is a great gift from God. That's why, although we're not the fastest or strongest or stealthiest species on planet Earth, God gave us his image, and he gave us a mind, and that can work in highly complex environments and adapt to them. And that's what human beings are. And that's one of those things, in addition to the spiritual part, where that person has that still small voice inside, or their conscience, okay, or their questions about why am I here, okay? That's that God image. That's that part of God speaking to us and calling us to consider him and if necessary, to come to him and accept Christ. That's pretty much it. Okay. Well, we've got the 16, and we're going to start with some cross joins. And you'll want to notice over there on page 599, he talks about the definition of a cross join, what that means, and he says it's a cross product or a Cartesian product. And what he means by Cartesian product, I'm taking rows versus columns, and I'm multiplying them, okay? If you look at the columns in a cross join, watch what's going on here. And this is the middle of page 599. We get the sum of the number of columns in the beginning tables. So that has an additive property. Then the rows have a multiplicative property. They're the product of the number of rows in the beginning tables. And so he shows us an example of that. And what this should take, and I don't want you to memorize, I get an additive property when I do columns, or I get a multiplicative property when I'm dealing with rows. What I want you to understand, okay, is that when we do a Cartesian product, the more rows we have, the more columns we have, the more data we get, the better we're closer to being able to leverage the law of big numbers, okay? And that is, the law of big numbers is large numbers, is very simple. I'll say it again. If you go out in a boat in the middle of the Gulf of Mexico and you fish, if you're out there for a week, you have decent chances of getting a swordfish. Or if you stay out there 2 weeks, the chances. But if you're out there every week, you're going to get one just simply because of sample size, just because you've sampled out there. So we try to do that when we start to look for patterns and characteristics, and they'll often emerge for us. So we've got that. That hopefully will give you kind of an idea of what we've got going on in terms of why we're doing these efforts. Now, the bottom of page 599, we've got 16.1, and I'm going to go ahead and open up the code for that. All right, and this is a dual code. In other words, it works with Access and Oracle. Yee. All right. Now we're going to go ahead and do our query. We're going to click Create. Okay. And I'll go to the query design and get rid of that. We'll go right down here. I'll paste in my query. I'm going to run it. All right. Now, the results set, let's look at that. It's over on page 600, excuse me. At the top, you see a beginning table of columns 1 to 2. Then you see another beginning table of columns 3 to 5, right? And they show you those columns, and you have over in that beginning table, you have 2 columns, which one of them has the number column, the other is a text column. And then over on the other table, it's the 1601 table, you've got the number, okay? And you've got a rate, and you've got another column there. So you've got 1, 2, 3 columns. And then the results set, you end up with 20, all right? And what you end up with actually is 5 groups of 4. 1, 2, 3, 4, and there's 5. And you'll see, and notice something very interesting, okay? We're gonna see some patterns. So what in the world are you talking about? If you look at the result table, okay, and you start to follow the output, okay, you start to look at that output, you're gonna see, all right, that we've got these tables, okay. We've got the F column, the F column 2, the section column, and we're in good shape. Now, I want to make sure here that, and I want to look at this for just a minute because something doesn't seem right to me. All right. Okay, we've got and we should have the text in there as well. Let's look here for just a second and see why we didn't get the text column. All right, I'm going to do some troubleshooting for just a second, because what I'm looking at as I'm going through this, what's over here on page 600 and what we've got doesn't seem to jive up because I don't see the text column, but maybe that's me. Let me go back up here. Well, I guess that SCO2L. Okay, I apologize. Now, we didn't use any column aliases. I'm sorry. And if we'd use the column aliases, then those columns would be numbered as they'd have headers that match those in the book. So if you wanted to do that, you want to change these row of titles, okay, up here, then basically you go in and you could use a column alias to get that accomplished. But still, that S column 2, you'll see the patterns, okay, where they go V, then W, then X, then Y, then Z, and there are 4 in each group, okay. And we've got those, and we've got the VV, the VV, and then we get to 25, and we've got the small. Now those should be uppercase, and I think what the author did to keep things simple for us is he also didn't use the case function to get them to be uppercase. But nonetheless, what you need to see here is this: that you've got 5 groups of 4. Okay, so this gives you an opportunity to look for a pattern. Now again, this column right here, these columns don't match up because we didn't use column aliases. All right, and then here we didn't use the uppercase to get those. To get all of them into uppercase, we'd have to go in there and basically take a look and put it in and use the uCase function. So that's the difference between what we've got here and what he's presented. And look, if you wanted to, you could always just take these, and rather than messing with the text functions, you could take these, throw them in. You could create a report with these basically and do some more formatting, or probably whatever you'd be working on at work, you could go ahead and put them into all caps if it was really necessary. But the whole thing is to see. We'll go back down here, and this is going to be 16.1, so we'll save it as 16.1. Okay, we'll have that. And the whole idea here is that you have essentially utilized, okay, that Cartesian product. You say, what do you mean? Think about this for a minute. If you go back over to page 599, the Cartesian product, when we talk about the number of rows, we multiply, okay? And if you go back over here to the top of page 600, okay, and we look at that, we get the rows in the cross chain, the number of rows in the beginning tables, and we multiply them. And we have 1, 2, 3, 4 rows in the table on the left, 5 rows in the table to the right. That's up at the top of page 600. So we get 20 rows. Okay, that's that piece of the Cartesian product. Then I have I add the number of columns, and as I look, I see 2 columns in one table. I see 3 columns in another. Now you can see why I said that we use this technique to exploit large sets of data that we collect and clean up, etc. So we can look for patterns, and there's a definitive pattern here. The first one is each of these letters show up, and they're there for 1, 2, 3, 4, 5, and then we have 4 of them. then we have another set of 4, etc. And so if you want to know in terms of how many records you'll generate, you can use that formula for the Cartesian product. But the whole point is this: the more data you generate, the greater your chances of seeing something. And that's what 1610 is all about. And that's why he talks about and gives us that example. Now, over on page 601 and 602, okay, he starts to talk inner joins. Now, we just got through doing a cross join, and that is where we've linked a couple of tables together. But we can also do an inner join, okay? And he says it's derived from a cross join. And notice there at the bottom of page 601, he talks about the join condition is a statement, okay? And they call it an expression or a logical expression. And he walks through what we get, okay? The only rows that get kept are those that are true. Otherwise, false or unknown ones get plastered away. And let's take a look now at 16.3. Okay, so we're going to generate 16.3, and that's going to be at the top of page 602. So I'm going to click Create, and I'm going to go down to the Query Design, and then down to the SQL, and I'm going to find my trusty data, my little notepad. Now, I'm going to select. Now, here's what I'm going to do. I'm going to get everything from A. I'm going to get everything from B. I'm going to identify the table A is that 1603 fruits table. Then table B is the colors table, okay? And I'm going to run. And then I have a where statement. The number in column A equals the color number in B. And you'll see this if you look at those two tables at the top of page 602. And you can see the logic of it. And then we're going to do the cross join of those tables. So we're going to copy this, okay? And so we're going to have a couple of things we're going to do. We've got our queries ready, so we'll pop that in. And we're going to run it. All right, and he shows us the result set that we've got, okay? And now I want to look at this for just a minute because we did a fruits A, the cards D. I want to see if we had to do something with another table before, because we used the join condition. Okay. Oh, let me see this for just a second. Yeah. So we've got the two tables. Oh. Okay. I apologize. I've confused you and myself in the process. Follow what's happening. I forget the author will do this. On page 602, he shows us the code, then the beginning tables. And then he says, step 1, form the cross join of the two tables. Now, this is what's going on inside the machine. You and I are doing this. That's what got me confused. And the second step the machine will do is to evaluate the join condition in each row of that cross join. Okay? And we end up where we keep only those rows that are true. And that's what we have. I apologize. I forgot to make a note to myself that result set in step 1 and step 2, he's showing us what's going on behind the scenes. Okay? So we run that code that's at the top of 600 off of those two beginning tables. The machine's going to form the cross join. Then it's going to evaluate the join condition, okay? And whatever is kept is the join condition that came out as true, or there was a match. And I apologize that botched explanation. And then he has step 4, and if we remove the evaluation, and then you get the inner join. Okay, and you're really not coming up with any big stuff. And the 16 through that results set, he's got the color of the fruit, so that's where we end up. Yeah. So now what we could do if we wanted to is go ahead and put the fruit into. We have the evaluation. He has the evaluation there, and he's built it in. What the author will sometimes do is build some of these and then pop it out at the end for us to take a look at. And that's what it looks like that he's done there. He's gone ahead and used a hard key, used a flag. So then we get to the step 4, okay? The middle of page 604, he walks you through the properties of an inner join, okay? What's going on with all of that, and he gives you some information about how they work, okay? And that's a lot there, okay? But it's I would not expect you to remember to memorize all of that. I wouldn't even do that. I'd simply go start to look and say, okay, here's what we're going to need to do. And if you do much coding, which I doubt you would. But here's the whole point again, and this is going to be 16.3. So we'll save it as that. Is that we're able to take the data, okay, and I'm going to save this as 16.3, and we can literally manipulate the table itself, or take 2 tables and really manipulate them to get a rich pattern. You say, what do you mean? Well, if you look at these at the top of page 602, you see fruits, okay, with colors. So we're seeing a certain pattern. We see that strawberries are red, apples are red, bananas are yellow, and then we also find out that strawberries and apples can also be green. So we've matched them up. So we see a pattern now, and the big pattern is strawberries can be 2 different colors, okay? Apples can be 2 different colors. And then we have bananas that are only 1 color. So we have some of these fruits. One of these fruits, banana, it can only be 1 color. The others can be red or green. And so that's a pattern. And this might be zip codes out in the rural, and this might be zip codes, time of day of transaction. This might be method of payment, any one of a number of variables. And this is just a baby example, I understand. But if you handled a big data set and you start to see that 85% of these are in 74804, you've got a good clue that something's going on in that county, okay, or in that zip code that you might want to take a look at or know about. So that's going to be 16.3. He walks us through, and then 16.5, and there's an error in that in 16.5, and we'll just pop it up here real quickly, all right? And as he tells us there, there's an error in this 16.5 because the product code's not included in the join. Okay? We don't include the product code in the join. And if you want to see what he's talking about, go to the bottom of page 607. Okay? And this time it's correct because he's added the supplier ID, okay, and the product code, another statement of equivalence, and then a third statement where for the lunch ID equals 2. But you'll notice when he left out that product code, then it gives us that incorrect set of data. So you always, it's again one of these things is, you have to take a look at a set of data and say, is this what it's supposed to give me or tell me? And that's hard when you've got large sets of data. But again, and when you're out working in a graphic user interface, say like something at SAS or you're working with SPSS, or you're working with Excel or any of those kinds of tools, it's easy. Not Excel. I'm talking about a commercial product like Oracle, SAP, SAS. You can get yourself into a situation where you've left something out and you're going to get a whole bunch of spurious data. And the only reason here the only reason here that you don't just try to generate more rows is because you don't need to. You're looking for a pattern. Now, this is something this is something that will take you some time when you're out dealing with stuff in the real world and you're trying to make sense of some disparate sets of data you might have, or a whole bunch of records that you have to run and to look at, and you'll hit that wall where you've left something out and you're just not getting what you want. The code will run, or the query you run will execute, but you won't get the data that you want. So that's why you always have to go back and think your way through what you're going to do. Now, most of the work's will be eliminated for you because the IT department plus the executive team or whoever will say, for this person at this level, here's what they can do. Here's what part of the table they can access. Okay, here are the methods they can use, and you're usually limited to some pretty simple queries until they trust you, etc. Okay, so that takes us through the incorrect versus the correct join. And again, the reason it was incorrect is we didn't have the product code involved there. So if we want, we can we'll go ahead and run that 16.5 and we'll talk about what it is. All right, we've got two pseudonyms for our tables because we're working with two tables, Table A and Table B. And in the from statement, we have to declare what they are. And that's the lunch items is A and foods is B. Then we come down and we have the where statement. And we do the statement of equivalency for the supplier ID. Then we add the product code statement of equivalency. And then we add another qualifier in where we say, and the lunch ID equals 2. Okay? And that's just further on the table A, we're just further refining the data just a little bit more. Okay? And so we're going to copy this. And we'll create, and we'll get the query design, and we'll go to the SQL view. Now, that's the result set that you get. And you say, does the author think I'm stupid? No. What the author is implying to us, and I'm going to go beyond the textbook a little bit, okay? And we're going to take a quick trip a little bit back to statistics. And I know some of you have your garlic out and you're holding up your cross. I understand, okay? When we run a join like this, we're on a fishing expedition, all right? We know that we have we have some elements on which we can join these two tables, okay? And we know that we can join them on supplier ID and on product code. Now, that's fine. But again, back to this business of using big data and using the law of large numbers to our advantage, there might be 3 or 4 other comparisons that we can make that will enrich the data, okay? And so that we not only get, we not only get the supply, we not only get the data set here. This is going to be 16.5, okay? We not only get the data set. Now let's say this for just a second, make sure we got 16-5. But we also want to start to go looking for anything else where a match will describe, will show us that there's a pattern. 2 things matching up together are a pattern if they continue out into space and time, and you can be reasonably sure that the observation points around that comparison stay fairly close to a line like a regression line, and you don't have a whole bunch of outliers. But if you start off and you've got a lot of outliers, that means you need to do some parsing. There's some statistical treatments out there, like the least squares treatment, that you can run to a set of data. But what you can do more simply is just keep adding in dimensions, okay? Or better yet, add in a subdimension, and that will give you a richer set of data. And so you're saying, Dr. Harmon, what I should do is I just keep adding some more stuff in. Exactly. And this is, there's some statistical tools out there that use what we call the least squares method that will let us look at those, add and load them in. There's some multivariate analysis. In other words, a multiple ANOVA. You can do that type of thing with tools like, say, an SPSS, etc. But the whole point is, if you're going to look for patterns, you may have to do it on more than 2 or 3 criteria. Okay, now over there in 1660, he says, using a cross join to list all the possible combinations of a car, and he walks us through the car types and the car color. And then he creates the 2-dimensional grid. Now this is what I really suggest that you pay attention to, because here he's literally developing a chart that will tell him, okay, how many records he'll generate. And he knows, for example, here in this book of the text, page 609, he says, I'm going to create 12 records. Where will I find data that fit a pattern that are more signal than noise? More noise than signal. Well, at 1,000 cases, or 10,000 cases, or 20,000 cases. Okay? And that's just the simple answer. Now, we have to be careful with what I'm saying, because what I'm saying is the law of large numbers works to your advantage if you collect the right numbers. That's the if part. If you don't collect the right numbers, you're wasting your time. You'll get a mathematically correct result, but you won't get a what one could call a useful result set. something that you can actually apply and use. I'll give you a good example of this, all right? Back at the turn of the century, psychologists and sociologists started to develop statistical techniques. You've heard of like his statistics of Tucky's team. There are other statistics you'll notice they're often with a person's name on them. You say, well, why? What's that all about? Well, what it's all about is most of the statistical treatments that we have today were derived from folks in those professions who had to find a way to make linkages because they knew there were linkages there in certain aspects of human behavior. They just needed the tools to get it done. They needed the observational tools and they needed the data analysis tools. And before that, obviously, you need to have the conceptual background and know what question to ask. Okay? And that's really what it boils down to. You said, well, that sounds reasonable to me. I can go for that. And of course, it makes sense. a lot of things in business are pretty simple, okay, and they make sense. And again, that's one of these where we might even here, as you've got over on page 609, okay, 609. If you look to the bottom, you'll see you've got the 24 rows. You get 24 rows in the table as you do the cross join. And running the code here, you'll notice he kind of departs from running a lot of code. And let's look at 16.6. Let's just run 16.6 so we can go ahead and bang up our wrist and get a little bit better. Nobody's lived till they've had some carpal tunnel syndrome. I'm just kidding you. All right, we're going to do that. We'll put that in. We're going to run this. And there's the car type and the car color. Okay, so far so good. And he walks us through those two beginning tables into a result table where we have the car type and the car color. Okay, so we could now I've got two beginning tables. Okay, I think I'm right about that. This is 16.6. I'm going to save it right now. And we're going to take a peek out of the hood here for just a sec. No, I want to go down to the SQL. It's not going to tell me anything. And I'm going to run this back to the data sheet view. Okay, now let me take a minute and talk about this. We've got Chevys, Fords, Toyotas, and Volkswagens, okay? And we see that Chevys, we have green Chevys, we have a green Ford, we have a green Volkswagen, and we have a green Toyota. I can surmise from that the color of car that's attractive is not brand driven. It's not driven by brand. It's noise, meaning it's just it's personal taste. Now, I don't know how many people do you, when you go to school and you're hanging around, how many of you start and go, hey, I really like blue cars, or I really like black cars, or I really like white cars, or I like red cars. I don't know that you have a lot of conversation about that. If you do, go to student services immediately. But the bottom line is this. The patterns, if I have enough records, and I see that continue, that I don't see a whole bunch of consumers who purchased a new vehicle, and for that vehicle component, I don't see the greens in. I'm going to go. I'm skeptical that really is a feature that's attractive to people, or a feature that would drive them to buy the vehicle. They bought the vehicle simply because they liked the vehicle. Okay? And that's what the author's trying to convey to you, so that you understand why we use these joins, the patterns that they can establish, and how we need to be careful to make sure that we don't miss a pattern. So we've run 16.6, okay? Now, over on page 611, and you'll notice as we've gone, I'm doing more and more lecture than running code. And that's because as we get down to these pieces, these final chapters, these are where the money's made, okay? Because you're able to leverage all the data and to get something from it, and you're not letting the data leverage you. And so he shows us some other layouts, and he talks about two-dimensional tables, okay, where I've got two-door cars or four-door cars, and then I've got the colors. And then so he shows this layout in one table. Now notice, again, this table, layout 2, is the composite of those first two tables. Okay? Then he begins to walk through the data flow of how all this happens and how you avoid a cross join of large tables. What he says is you take two tables, okay, and you create the cross join of those two tables. Then you select the data you want, okay? So you've got you get step 1 in these two tables. You get only the data you need, okay? And then and that shows up then in a view or data set, which the result of that, and then you extract from there. And that's the data flow. And notice what's happening as you go deeper and deeper, as you dig in, you come to the result table, and the result table typically will be smaller than the level above it. So that's why they talk about it as mining, and like data mining, and that use those types of terms. 16.9, okay, he talks about joining a table with itself. And he asks a stupid question, why would you do that? You do that because you paid to get that table. You had to capture the data. You had to get it cleaned up. You have to have it stored. You have to have it protected. So you should use it. You'd be pretty stupid if you didn't. So if you look at that, and let's find the code for 16.9, we'll run it. All we're doing here, we're looking for patterns. We're always looking for patterns. And we'll click create, and the query design, and then we'll go back to the SQL view and we'll run this. And you say, what does it matter if we see patterns? Well, if you're taking management science with me, or you've taken it with me, you remember that when you walk through using the solver, that you can choose the type of analysis or assumptions about how the data points are distributed on an infinite basis. And remember, we had some that were linear because they follow a straight linear trend, okay? And this is my chance to hone my annotation skills, so I'm not going to lose it, okay? So we've got those situations where we have linear trends. That's linear. Then we have those situations where they are nonlinear. And they're probably going to be either like this, concave, or convex. Marginal revenue. You build and build and build, then there's a sweet spot. And then with each additional item you make, that marginal revenue begins to shrink because of the law of budgets and constraints. And then you remember here we have a convex, and we've got marginal revenue here, and it's going to drop. Or this is typically is going to be like marginal cost. We're going to talk about marginality. So you can see these are distributions, and then there are some which are called evolutionary. You remember those, in which we have no idea what the result set's going to look like. If you've had me with managed science, you'll remember we do the algebra, we run the data, and we find that we can find an optimal solution anywhere here in this area. But anything outside of it, no way. Then we get this kind of thing, and the crazy one is when we get what we call an evolutionary, in which we don't know which set this belongs to. So the machine, just as it does its computations behind the scenes, says, okay, let me see. And I'll see if there's a pattern I can inherit. Now, you said, why are you getting off on this? Well, there's something important to understand. When we first started developing databases, we used a term of correlated data. Now, people who were in the social sciences went berserk because they said these data are not correlated. And people who were in computer science said, I beg to differ, because at that time, the way code was written, it was so specific to a particular address, i.e. part of the computer, that you were literally matching one area with another. Okay? And since all of the areas in a computer are going to perform the same for an executable code, you basically have that environment. So you can have correlation. Just like you have correlation between numbers, you're correlating space on the machine. Now, because we've moved away from having to actually use space in a machine to the cloud, we can run all of these comparisons and run all these queries, and we're not really messing with the underlying data set to begin with. And that's to help prevent us from having some kind of a disaster. So here's the cross join of this table with itself, and we've got columns 1, 2, 3, and 4. Okay, and we used a pseudonym for the tables A and B. All right, and we also utilized utilized a column alias. Now, the alias, of course, is when we see that word as. I'll go back down here to the SQL view. I'm going to have to turn this off for a moment. And we'll go to the SQL view, hopefully. Oh, you're not going to let me do that, are you? All right, you little weasel. Then we'll go back down here. Now let's get down to the SQL view. And now I can bring out my trusty annotator. Okay. And here we are. Now, I want to do that, and I want to put a circle here. So I'm going to look for a shape, but the bottom line is, well, here we are. Earth to me. My apologies. Right there, you see, we're missing the, we're using the alias. Actually, I'm going to reverse this. I'm going to eraser. And then I'll do the draw. And there's the as. Okay, that's the column alias. So we run the inner join. Okay, we do the cross join, except, pardon me. And notice we haven't used any qualifying statements. We've just taken the tables and run them and put them together. And that's what we get in terms of the result table. There's some more valuable information over here. And so I want to go ahead and I'm going to take this and erase it. We'll get this. And we're going to look at some other issues involving joins that will be of some help to us. So I clear this off and clear this off. Amazing, isn't it? I'm telling you what, I think if we were in class today and I were doing this, you guys would be applauding and stuff. That's my fantasy, but I don't think it'll come true. Well, that we've done 16.9. We'll call that one 16.9. And 16-9, we're okay there. Now, page 616 shows us an example of a self-join. Okay? And notice what we've got going on here. We're joining two dimensions that have a natural proclivity to occur together. In other words, correlated data. You say, what are you talking about? I don't know. Let's find out and see if I do. Well, maybe I do. If you look there at 1610, page 616, in the middle, you're going to see that table. And notice how the manager ID, okay, and the employee ID are linked up together. Those two occur naturally. If employee 747 reports to Supervisor Smith, they are joined at the hip in terms of correlation for data, correlated data, because one is the supervisor of the other, one is the employee of the other, and so they bring with them all of their attributes, and then you deal with that condition in which they're joined, and that's really the simplest way, and to show you. And then notice he shows you those employees table, and as he make two copies of it, okay. And then in the middle of page 617, he shows you the join condition where they're joined by ID, and 1610 is the code. But that graphic over there, that little illustration there in 616, really shows you everything, okay, when we can link, how we can do a self-join. And this is the most economical way to do a join. We're only working with one table. Now, you've heard me rail about the raw input, like putting data into a survey or transaction data or all of that. And I'd say about half the time, you don't get good results because you didn't run the query properly. You didn't find those two things that naturally occur together. Okay? Or the other 50% is you just simply don't have the dimensions that you need. You've not collected the type of data that you need. That's all there is to it. Okay? If you don't have those dimensions and you don't have records for them, for example, if you have a bunch of records with null data, you're going to get some pretty nasty, spotty looking reports. And you'll have paid money to have them. And you'll go, oh, I didn't really get what I wanted to. Now, as you come down here on page 617, the bottom there, there's 1610. And 1610 is littered with all kinds of gadgetry, okay? And one of them, of course, is we use our friend, we turn our tables into pseudonyms, okay? And pardon me, not the table, but the columns that boss last name, the boss's phone number, okay? And then we do a left outer join of the employee's boss on the employee.manager ID equaling the boss's employee ID. So there's a lot going on there. But notice we've done the outer join. So a left outer join. So we're getting everything out of the parent table, and then that from the child table that matches up. And we run that code, and it's going to give us this. We'll go ahead and click create, and then we'll click create, and we'll do query design, and we'll close this. And we'll run it. And there we go. And the result set's over on page 618. Okay. Now, there's some things that he does over on page 619 where we find the amount of time lapsed between one event and the next event, and there's just a whole bunch of markup that you have to use. Now, this thing at the top says Oracle SQL. All right, and I want to dive into the code for just a second. I don't want to belabor it because we got 3 minutes left. Okay, and first of all, if in Access, we cannot use the to-character function that's right here. Okay, so that one's off the table. Now on this fourth line here, the V time, we would use round, okay, in order to get as minutes elapsed time. And notice we have as minutes elapsed time. We've got another column alias. Then we come down, and here in the where statement, we identify the two tables, what's A, what's B, and then we have this where statement, okay? And we use an operator, a row function, +1 equals B.sequence number. So we've added them on. We've added +1, okay? And then we order it by sequence number, and there's the result set over on page 620. There's a little bit too much work of cutting it and picking at it, okay? But it shows you can look at stuff you can use this to set up a chronological order. The rest of 16 begins the long, slow dying march on using the crosstabs function in Access. And I just got to tell you, I think it's clunky. It doesn't work good, and we'll call it 1610. And so I think you're better to export your data and put it over into a pivot table. Now, that's just me. And we'll save this as 1610. Often you're not it's just so clunky. Now, there are some other commercial products out there that have you use an expression builder, and they're fine and they're okay. And when you run into one of them, best of luck. But if you've got to use an access for some reason or weird reason at all, or if it looks clunky, because remember, there are companies out there that sell these, that take these tools, and especially if they're open source, and they rebuild them enough so they say, okay, I can slap a patent or a license on it and claim it as mine. And you'll notice here, if you look, you have some severe limitations on it. So I'd say stay away from trying to do those operations. The author just goes on and on and on, just like I do in showing you how to do those cross, how to use the cross tab. And the problem is you're very limited in terms of the rows and the columns, and I just think it really does make it too complicated and probably not worth the answer. Okay, so if you really want to see page 644 and 643, he has 6 ways to make a crosstab query, and the result is a matrix with a bunch of binaries, 1 versus 2. And I guess you could use some color, use some standard formatting or color formation to see how things are clustering together or if they're apart. And he walks through some more working with tables throughout the remainder of the chapter. And again, I just don't like the expression builder in Access. You'll see for Access that on 644, I made a note to myself when I looked at it, I said, use the GUI. And that is go into that design view and use it. And the design view will generate the code for you, just like the code will generate the design view. Okay? Folks, it's a few minutes later. Thank you so much for your time. And I think we've done 16. We've exhausted what I think is going to be useful in it for you. And I will see all of you on Thursday. Before I go, does anybody have a question I could try to answer for you? Anybody? Okay, seeing no questions, I'm going to stop the sharing and then end the recording. Thanks, folks. I'll see you Thursday.